This is a shape memory polymer. Heat it up and it curls in on itself. Cool it down and it resumes its original shape. They have lots of different looks, but they all work on the same principle.
There's lots of experimentation right now in materials that are responsive to environmental cues.
It's an engineering challenge. With support from the National Science Foundation, a multidisciplinary team of scientists at Texas A&M University are working to make buildings more energy efficient.
This is something that is a new field, it's very cutting edge, and these materials are being developed on a daily basis.
They're using nature-inspired design and new materials to create what are called smart building skins. Typical structures have the basics: walls, windows, doors. A smart skin would allow a building to breathe, much like a living system. For engineer Zofia Rybkowski, the idea goes all the way back to an undergraduate biology class.
I remember my professor drawing essentially this beautiful leaf and talking about stomata, and this idea that on the underside of the leaves we have these pretty much microscopic openings.
So-called guard cells surround those openings, plumping up and pulling them wide in wet conditions, shriveling up and pinching shut in dry ones. An elegant design for sure, one she remembered later as an engineer with a strong interest in architecture. It got her thinking.
Can we start to create a system that is sort of self-regulated based on the properties of the materials themselves, the inherent properties of the materials themselves?
These shape memory polymers are the brainchild of Mariam Mansouri. She and the team mix up a chemical cocktail that they bake into wood. The new composite material not only takes on and holds a precise shape, but it changes its shape in response to different environmental conditions.
So these factors can be heat, can be light, and they react to that.
They activate on their own. No one has to switch them on or off.
When it's hot, we want the building skin be open to absorb air. And when it's cold, we want it closed, without using external mechanical devices or electrical devices.
They're working on other approaches here too. Architect Negar Kalantar is harnessing the power of 3D printers to fabricate blocks like these. Walls designed with them might look like this, or this.
So these look like the modular concrete or bricks that you have, but it has a special design that when you put them together, generates some aperture that air can go in.
The holes in the blocks are shaped like nozzles, designed to naturally draw fresh air into the building.
Instead of having the whole thing smart, we can just smart this part. Means that this part can open and close. It looks like the aperture of your eye. That's a small aperture, can open and close the whole system.
But what are the most efficient shapes for the holes? They're putting a lot of work into that and testing many designs. These are all early iterations. They're making bigger prototypes too, so they can test them at a larger scale. And they're looking at how new materials could self-regulate more than just temperature, but air quality, water conservation, and more. It's a real team effort.
There's many possible solutions to this problem. And so the idea was to get all of our students engaged, 66 undergraduates and graduate students engaged, to also help develop some of these new strategies.
The through line for all of it is sustainability.
That is the big picture. Can we do more with less? Can we harvest what already exists in the environment and incorporate that into the anatomy of our buildings?
Engineering smart building skins for cleaner, greener architecture and design. For Science Nation, I'm Miles O'Brien.